Hello viewers of YouTube, and you are watching Transactionality. And in today's video, we will explore the key decision makers when it comes to choosing between relational databases versus NoSQL databases. But before that, if you're new to our channel, a warm welcome to you guys. We are engineers from one of the FAANG companies, and we like to share our hard-earned lessons, tips and tricks with you guys, which can help you to crack your next tech company interview. So let's begin. So you might have already seen a lot of video on this topic till now. So we are going to take a different approach. Basically, our main goal is to not load you with boring details but share practical advices when you are tasked with this sort of decision making, choosing between different databases. So with that notion, let's get right in. So first off, we will see that what relational databases really are. I think most of us already know the answer to that question, but it is always good to be on the same page. Then we will see what NoSQL databases are and what are the basic differences between NoSQL databases and relational databases in their composition and interaction pattern. After that, we will jump into the meat of this video, which is listing different advantages of NoSQL databases over relational databases, and why different companies like Google, Facebook and Uber are all using more and more of NoSQL databases with each passing day. In the end, it is not all sad and gloom for relational databases. Don't get us wrong here. There are still plenty of market for relational databases. It is just that they are not able to keep up with the progress and success of NoSQL databases since the beginning of 21st century. Alright, relational databases. So this is basically a software application to store relations among data. So you might be asking that what comprises of this relationship? Basically any or every piece of data that has some sort of relationship between them is a valid candidate. Like in real life, John is a son of Will is Jane's husband, and same can be applied for a user might be living in a city and a city has a name. It might belong to a state and a country possibly. So from the above schema, we can store everything in one big table where all users information like first name, last name, city, country, everything is in one place, and we have this one big table. Or we can separate it into two tables. The reason for that is that city data is a little bit redundant, and by moving it into its own table, we can really save some space. But when we move cities data into its own table, we have to create links or references back from the user table to store this relationship in different table. So this is where we want to introduce the concept of primary key and the foreign key. So basically primary key is a unique key that system and user generate to uniquely identify each entity in the table. And this is non-optional, where every table has to have a primary key. Now, when we would like to link London City with John token user from this table, we only have to do is to reference the city1 primary key of city table into its foreign key column for the user. So this is how we are making this sort of relationship between the user table to the city table to store this information. So this process is also known as normalization, where instead of saving data in one giant table and eat up a lot of disk space, we placed data in loosely coupled tables. But as we made some progress in the database world, instead of just saving relationships between data, we also started associating this concept of transactionality to the whole updating and reading process of the database. So here we have a very simple ATM transaction where a person is trying to withdraw $300. So in this entire process, we want to make sure that database is never in a state where we have deducted $300 and at the same time a person hasn't got the $300 from the ATM machine. So a really good question to ask that how do we make sure of transactionality? So this is where relational databases apply the concept of ACID properties. ACID is short for atomicity, consistency, isolation, and durability, and helps us in ensuring transactions between different tables. But if you're new to the concept of ACID in general, we have covered this in detail on our website, and you can find the link for that in the description. You can think of ACID as a promise for relational databases that no matter whatever happens, you won't store corrupt data and you won't read corrupt data for as long as possible. So that is pretty much it that we would like to cover for relational databases. So the key takeaways here are that relational databases are used to persist relationships among data. Data is stored in row or column manner. You might have to think about the schema. This is something we will cover during the differences of NoSQL versus relational databases. So keep on watching for that. Now let's move on to the NoSQL databases. So NoSQL is sort of a rage term from database developers. Back in late 90s, developers were looking for a better option than the famous Oracle's relational database. So if you go to Google or Wikipedia, you will see that NoSQL stands for non-SQL or not only SQL. Basically, it is anything but SQL, which if we peel a layer down, doesn't make true sense since SQL is not database, it is a query language. Like you might have seen select count star from users, which is written in SQL. So SQL is a language, not a database. But NoSQL got popularity and no one bothered to change it since it was a movement against relational databases rather than a singular product. But as the name suggests that we don't use SQL to query our database, we use different custom languages for each of these NoSQL databases to interact with. Sort of like this. So on the left side, we have a query to store multiple users' information into a user document via MongoDB, which is a NoSQL database. And on the right, this is how you will store the user's information in a SQL query. So there are some differences. As you can see here, you would have to learn the correct pattern of this insert query, whereas here you can just be a little bit more fluid. Now let's look at the advantages of NoSQL databases over relational databases. Since we are living in digital era, talking about millions of users or billions of requests per second is not unusual. So what happens when your database can't grow more than 4 TB of the hard disk where it was earlier hosted? Well, there are two options. You can either buy another cheap 4 TB hard disk, tell your database engine about it, and it gives you a little bit of a breathing room until you run out of that as well. Or you go shop for a bigger hard disk like 8 TB or 100 TB since you want to future-proof yourself and migrate all your data from 4 TB hard disk to this new bigger hard disk until you run out of that as well, and then plug in even bigger hard disk. This is what we call horizontal scaling and vertical scaling. Formal definition would be horizontal scaling is where you scale horizontally and employ more of similar resources linearly, whereas vertical scaling is where you add or replace the resources with bigger capacity. So to better visualize, think that of a skyscraper in downtowns as a prime example of scaling living space vertically, where townhouses in the suburbs scale horizontally since we have a lot of cheap land available to us there. And that is where NoSQL has an upper hand over relational databases. One would not have to think about scaling or costing associated with it. When they want to scale, they can just do it when the day will come. Now, another big advantage of NoSQL over relational databases is that NoSQL is schemaless. As we have already seen that with NoSQL, we don't have to define the schema. Schema is a sort of a definition or model for your database. And this will be better explained with an example. So let's say you have a users table. You started off your schema pretty basic. You started adding first name, last name, and the phone and address and city in your table. But as now this thing is running and accepting new users information, you suddenly realize that you missed to add a horoscope attribute in your table. So now you have two options. You either junk your entire table, move its data to a new one, and then you start adding the horoscope with the null field for all the older users, and newer ones will have their horoscope field. Or this is where NoSQL comes to help. With NoSQL, you can dynamically extend or retain your schema. If you need to add horoscope, you just start adding it with the next user in the line. All the earlier users would not see a difference, just that they won't have horoscope until they would update their entity when the next time they come to update their profile. But in this case, no migration required to the new table. This is really good when you are starting off a new project and there are a lot of unknowns which can delay your project. With NoSQL, you can punt all that decision making to a later point when you would know any better. Now, another cool thing about NoSQL databases is that there is a very minimal learning curve. Since a lot of NoSQL databases already come with their own library or tooling to facilitate the interaction with the database. So in this picture, we can see that we can interact with the DynamoDB using the annotations and annotate our POJO like this. So here, add DynamoDB table is to indicate the table name that we want to fetch the data from. Then each column would be annotated using add DynamoDB attribute to tell that which attribute we want the information to feed it into this particular string or integer. And this is a lot easier because we already know how to code in Java and we don't have to learn a new language such as SQL in case of relational databases. Now let's look at the use cases where we do want to use relational databases. So as we have already mentioned that relational databases use ACID properties to ensure transactionality while updating or reading database. This is essentially necessary when you are interacting with highly sensitive data, for example, e-commerce purchase order, bank account information, or stock market data. All these areas have tight transactionality requirements, and that is why we are still using relational databases in such scenarios. Another big advantage of using relational databases is that it has a higher read throughput. So sites like Stack Overflow store their forum information in relational databases since they know that their database schema would hardly ever change. But they need faster reading speed to serve millions of users per second. With that, let's look at the key takeaways of this video. So whenever in doubt, choose NoSQL. But when something has matured a lot, go for relational databases. Select NoSQL if you have scalability as an issue. Select relational when transactionality is on the line. Select NoSQL when you want to get going and don't want to bother learning another language, aka SQL. And here are some more key points that you can pause the video and read over. But with that, we would like to end this video. This is definitely not the end of NoSQL story from our end. We have another video that goes into major categories of NoSQL databases in detail. So you definitely want to watch that. And if you like this video, click the like button. And if you like this video, click the like button. We would highly appreciate that. Please subscribe to our channel and hit that bell icon so that you will be updated about our future videos. Also leave us a comment if we missed anything major or important, or just leave us a suggestion if we can improve. Also, if you want an in-depth explanation of this video, please head over to our website www.techtakshila.com. We have the link for you in the description. There you can find several brain exercises to tune your knowledge. As always, thanks for watching. Stay tuned. Types of NoSQL databases is coming up next.